Hello, everyone, and happy CircuitPython Day 2025. This is a very special session because we are joined by CircuitPython core devs Scott and Dan. Hello, and thank you for joining us today.
Hi. Hello,
Thanks for
everybody.
hosting.
Of course, yeah. So Scott and Dan are going to talk about CircuitPython 10, new features that are coming out, and you're also going to be talking about, hopes and dreams for the next year in CircuitPython. Why don't you guys kick it off talking about what's new in CircuitPython?
All right. So CircuitPython 10, we tend to do a major release about once a year. I think CircuitPython 10 is a little overdue because we haven't had a major release this year so far. But we've been working on it, and I think we'll definitely get it out by the end of the year, if not a lot sooner. I was thinking about it. The core reason that we wanted to do 10 was actually a partition change on some of the Espresso boards. We had added Bluetooth low energy support in 9 sometime, but we're unable to fit it in the builds for the 4 megabyte flash Espresso boards. And so one of the main things that is why people need to pay attention, which is what kind of major versions are like, you might have to change something sort of thing, is the partition change for those 4 megabyte boards. But the benefit is that we had been saving space for over-the-air updates, but in practice we don't use it, and so we've decided to remove that extra space for over-the-air for the 4 megabyte boards, and instead extra space for more functionality. For example, Bluetooth being the main one. So that's that was one of our motivations for doing a CircuitPython 10, and then as we do 10, we collected a lot of other minor things that we bring along with it. So Dan, do you want to talk about a few other things?
Sure. So as we mentioned, we have this extra room, and what you'll have to do when you upgrade to CircuitPython 10 on these Espresso boards with 4 megabyte flash is that you have to update the Tiny UF2 bootloader if you're using the Tiny UF2 bootloader, which most people are. And there's already some web pages on all our boards about how to do that. And we'll continue to explain how to do that in sort of a clear way. There's like 4 different ways to do it. A lot of them are browser-based, so you don't have to like download and install tools. Right. So it makes it really easy.
And the reason for that is that it's the bootloader that's actually setting how much space CircuitPython has. What CircuitPython 10 is doing is like we're allowing CircuitPython to be bigger that won't fit in the old space.
Yeah. On Espresso boards, the flash is divided up into partitions, and the boot manager manages those partitions. So it only loads CircuitPython into a particular partition. It's like the same kind of thing of partitions on your hard drives or something like that.
Right.
You might be familiar with.
And there's a graphic actually in the page that's been linked into guides about updating the bootloader too, that can kind of visualize it for folks to see how it's changed.
Right.
All right, great, thank you. Yeah, that should make it really kind of clear what's going on there.
Right. So your CircuitPy drive stays in the same spot. What changes is you lose the over-the-air spot.
Yeah, it's when you do an upgrade, it's sort of possible to do it without damaging CircuitPy, but it would probably be better if you just do an erase. So save everything off your CircuitPy drive and then put it back.
Yeah, good to back up.
Yeah, never depend on it not being smashed.
Right.
So some other things that now that we have this extra space. Another thing that we did is that for all kinds of network stuff, not BLE, but regular networking stuff, there's something called the root certificate list, and that's used to connect to things over SSL, like HTTPS. And you have to have this list of root certificates so you can figure out which sites do the security and cryptography stuff you need to talk to a site in an encrypted way using HTTPS. So we used to have a kind of a most used lists of these root certificates, but we'd always like there were always some that people didn't get. People would say like, oh, this NASA site doesn't have,
Right.
the right root certificate or something. So now that we have the space, we're using the full root certificate list. That's the same one used by, it's published by Mozilla, so it's used by the Firefox browser. It's used by curl. It's used by a bunch of other browsers. So we now have this full root certificate list, and there should be a lot less of like, oh, I can't connect to this site over HTTPS or some other encrypted way because we don't have the root certificates. So that's another consequence of growing partition size for these
Right.
boards.
Right. And so, and I guess we should, in case people don't know what CircuitPython is, it's Python for embedded microcontrollers. And Adafruit is the company that pays Dan and I and some other folks to work on CircuitPython. So another theme of like kind of what's going into 10 is a lot of the work that we've done for some upcoming products for Adafruit. So FruitJam is one of those, kind of like the other key driver of what's in CircuitPython 10. So one thing Dan made a list, and one optimization that I had done is, so the FruitJam is an RP2350, which is the Raspberry Pi microcontroller, the newer one. And the newer one also supports external PSRAM. And the external PSRAM, I think on the FruitJam is what, 8 megabytes? It's quite large. Yeah, so there's both flash and PSRAM on there. And one of the things that as I was tuning and debugging and looking at the performance of the FruitJam, I noticed that the garbage collection times got really long. And what the garbage collector does is it, and like if you've ever done C where you have to say like explicitly allocate and free memory, a garbage collector kind of does it automatically. And the way that it does that is it just allocates and allocates and allocates until it runs out. And once it runs out, it's got to do this process of figuring out, okay, which of the memory that I've allocated is no longer in use. And if it's no longer in use, I can free it. And so what it does is it does this process of like scanning a bunch of stuff to find the things that are still in use. And I realized that in a world like FruitJam, where we are having big audio bitmap buffers and that sort of thing, the scanning process would scan through those big things in case they reference other objects, but we know that's not true at the time of the allocation. And so I added this optimization to CircuitPython that basically says like, if you're allocating some big thing that's just an array of bytes and you know that it's not a reference to another object, you can skip doing that collection process. So that's another kind of main key thing that will help particularly large amounts of RAM in CircuitPython. And that's in 10 as well.
It can make a big difference. It can be like a factor of 5 or something.
Yeah, I did some benchmarking, and it was kind of the ideal case because I was just allocating a bunch of byte arrays, which we know are in that category. But I don't know how usable using 8 megabytes of RAM, of PSRAM, would actually be without it. Just because the garbage collection times were, I think, over a second, right? Like PSRAM, the external PSRAM is big, but it's also quite slow. So like doing that process is pretty tricky. And the way that the RP2040 and our RP2s and ESP IDFs get away with external PSRAM and flash is they put a cache in front of it. But that process of scanning just destroys your cache because you're basically looking at everything. So that's probably still true even after this optimization, but you'll just be loading slowly a lot less stuff with CircuitPython 10 too.
Do you want to say something also about, so if you look at the FruitJam board, you'll see that it has an SD card, a micro SD card slot.
Right.
And you could say something about auto mounting.
Yeah,
so SD card.
That's something that I wanted to do. There's a couple related things, like we wanted to make SD cards available over the USB connection. And then we also, in order to do that, we felt like we kind of had to have it like just work. But it also means that like the card is active even when user code is not active. So you could read off the card even if there's no Python VM code running. So I did some changes around that, and I think there's a bug open for me to look at still regarding that as well. But there's now a process, or like a better process for like locking and unlocking the underlying blocks of storage that allows us to more dynamically like give CircuitPython access or give access to the host computer that's connected over the USB device port. So yeah, for a few boards that have micro SD card slots on them, when you put an micro SD card in, it should auto mount and show up as /SD automatically. So your CircuitPython code no longer needs to do the initialization itself for that case.
Another thing that we added is that because FruitJam is going to be used for like a lot of games and things like that, where maybe the game wants to save settings or otherwise record some state. So we added an extra file system besides CircuitPy called CP saves. And the saves here just means like maybe saving game information. That was kind of the original motivation for the name. Right. And so that file system is writable by CircuitPython normally. Right. Normally, CircuitPython can't write CircuitPy drive without remounting it.
Right.
So this is an extra file system.
Right.
Is this file system also visible from the host computer? I don't remember.
It is, yeah.
Okay.
Yeah, so and that's definitely something we've heard feedback about with early CircuitPython 10 is that like, people say like, there's 3 drives now. We're like, because, yeah, so you'll see CircuitPy, you'll see CP saves. CP saves is only enabled, I think, for FruitJam, because it is something that happens at like formatting time when we partition the drive. So it's only on for FruitJam, I think, even though other boards could turn it on, but it involves changing like the storage allocation of the onboard SPI flash. So that's something you want to kind of do at the start. And I think it's a megabyte by default. So it's like an 8 megabyte flash, and we have 2 something for CircuitPy, 1 for CP saves, and the rest for CircuitPy. I think if I remember right, it's what the partitioning is.
Yeah, we've always talked in the past about should we have such a partition on all drives, but usually there's not enough flash space. Because
I push back on that.
If you ever want to decide like how much should be read write and how much should be read only, like people's use cases vary, and so you don't know whether you have a small program and a lot of data or vice versa.
So now in CircuitPython 10, so in CircuitPython 10 now you can have up to 3 drives at the same time. You'll have CircuitPy, CP saves, and your micro SD card all showing up. And you can use storage.remount to decide who can be able to write it. But I think the default, if I remember right, is the host can write CircuitPy, but the SD cards and CP saves are writable by CircuitPython and read only to the host. Yeah. And we should point out, because there's a common misconception, even though it's read only, it doesn't auto update if you write to it. So people think that they can write data from CircuitPython to their SD card or CP saves and then immediately see it on the host. And that's not the case, because the host doesn't expect the device to be able to change the file system out from under it. So if you are doing that, you have to actually take USB down and remount it on your computer to get the latest version of your file system. But that's a gotcha that people run into for that.
Yeah, USB drives, a host computer would not expect a USB drive. Would expect a USB drive to be a completely passive thing and not change things out from under it.
Right. So, yeah. When we tell the host computer we're read only, it's more like old floppy disks times where you'd have a slide switch on the disk itself to make it read only. Like, it's really dumb.
Yeah. and the host computer says, "Oh, it's read only." Like I can read it once and it'll never change. And obviously,
Right.
that's not the case here. Yeah.
Right.
Yeah.
It's really tall, really small. I could just cache it all.
Right.
The other big thing is I did do a lot of USB host work for the Fruit Jam. I don't recall if that's in 9 or not, actually. But that was a lot of the work that we did. Is like on the Fruit Jam here, we have 2 USB-A ports, and they go to a little hub chip next to this Stemma QT, and then they connect to the RP2350 for USB host at the same time that we're being a device. So there was a lot of work at getting that pretty stable, but it's also something to expect that people may find USB devices that don't work with it, and we'll either have to fix it or come up with a way to another device to use.
Yeah, and I would say the support is early, so there are features that you might want that it doesn't have, and things like that, or kinds of devices that aren't supported. Yeah, for host, but keyboard and mice are supported right now. At least certain ones work well. Sometimes there are idiosyncratic ones that won't work
in boot mode as well. So mice particularly can have all sorts of buttons that don't necessarily get mapped into CircuitPython. Yeah, and since we're looking at Fruit Jam, the other piece is the DVI video. So we did some work to auto detect the monitor and pick a mode that is better proportions or aspect ratio for the display that we think we're talking to. So kind of the de facto is 640 by 480, but if we think that we're on a 1080p or a 4K TV, for example, we'll do this kind of like somewhat obscure mode, 720 by 400. That's more widescreen. But that mode actually has its roots in like a text mode from like way back in the day. Like the original IBM PC, I think, was actually like that resolution for text mode. So we'll try that if we think that it would be better to be widescreen. It doesn't always work for folks, but that's something we try.
Yeah, you might find older monitors in particular might not support a lot of these modes, so you might have to try a few. If you try
well, I think they support the modes. They just don't support our version of it.
Or our timing, right? It's hard to get the timing exactly right.
Yeah.
If you're having trouble, try it with a TV, because TVs are really good at taking almost anything. So if you think it might not be working, try with a TV instead of your regular monitor to begin with.
Yeah.
While we're talking about displays, there's kind of a whole new set of e-ink displays that are becoming available, and you might say, Scott, you've worked on quad color. Someone else contributed something called Spectra 6 color displays.
Right. So Spectra 6 is used by some Pimoroni products. It's a 6 color thing, not a 7 color. So we actually have 7 color support in CircuitPython already. We thought we would sell those for a while, but the challenge with e-inks is always stocking them, because I think what Lady Ada was saying is that like people who make like shelf tags, they'll come in and pay a supplier to make 10,000 of something, and that's the like you take the panel and you put the driver chip on it, and that combination of things, and then they'll make 10,000, and then they'll never make those 10,000 again. But like 5,000 will go to the person who ordered it, and 5,000 will get sold elsewhere to like Adafruit, for example. So like keeping up with what's available is always kind of a challenge in e-ink land. So we have 7 color support, but we don't really use it in Adafruit products. Spectra 6 is Pimoroni, and somebody contributed that, so thanks to them. And then we just started stocking quad color, which is black, white, yellow, and red. And so I just added support for that. So the support for that, like CircuitPython has 2 ways of supporting e-papers. Liz did the other way. There's an EPD library that kind of does it all on its own. And that is quite equivalent to the the way that Arduino does it. And then we also have like native display IO support in CircuitPython. So display IO's strength is that it is a standard API, and then it does its best to interpret that for the particular display. So you can give display IO a full color image, and it will do a conversion to these 4 colors, for example. And so what I added in order to support this is the ability to tell the display IO driver, like, we had this notion of a highlight color. So we already had support for black, white, and red usually, although it's configurable because that color was, we also had, I don't know if we stocked, but there were also available like black, white, and yellow. So like what that third color was is configurable. So what I added was the ability to add a second highlight color. And what it does is it figures out, like, is this pixel pretty colorful? And if it is, what is the hue of that pixel? And is the hue within a particular range of the highlight color that you told us it was? So like, you told us the highlight color is red, and we decide if a pixel is red enough to be red. Otherwise, it's just black or white. Is how that kind of works. And now we do it for 2 different highlight colors instead of just one.
All right.
But
So
yeah,
go ahead. Yeah.
I've just been like, display IO has gotten, I think, some frustrated some people because it's quite slow. But I think the fact that it's kind of universal like that, where you can have something display IO show up on e-ink, but then you can also have it show up on the DVI output of the fruit jam is really cool. And I think people don't fully appreciate that portability, but I'm quite proud of that part of display IO.
Another thing I would say about display IO is that we refactored the names of the modules so that everything wasn't all underneath display IO. And so that change was made in an upward compatible way in CircuitPython 9. And in CircuitPython 10, we're going to drop the old way. So you've been getting warnings in CircuitPython 9. And
yeah, we enabled those, right?
Yeah. And now we're going to drop the old names completely in 10. That's what we can do on a major version change. We always try to have one version in between where we support both. Not always, but usually. And so then on a major version, we'll make some incompatible change. So is this an example of that?
Right. Yeah. We try to have two versions that we kind of support at any one time. When a stable release is new, it will be the old stable release and the new stable release. And then basically after we feel like the old stable release is not recommended or used anymore, and that's usually also about the time that we're starting to do pre-releases of the next stable release, that's when we'll actually switch things over. Like for a while we'll support 8 and 9 in our libraries, and then at some point we'll decide not to support 8. We'll do 9 and 10 instead. And we made a mistake at the start of 9 to turn those warnings on at the start, which is bad because if you follow the warning and update it, then 8 wouldn't work anymore. So we actually learned our lesson on how to do those warnings. So now those warnings are in 9, but they weren't at the start. Only when we're doing 9 and 10 instead of 8 and 9 did we turn them on. There's something else. Yeah.
Go ahead. Yeah.
Sorry, the motivation for the display IO change was that we had what we call display buses under the display IO module. But there are times where, in a MagTag is a good example of this, where we actually only want one display bus because we're like, the display is natively built in and we don't expect to support any other displays. So the naming change was to take something like 4-wire display bus and split it out into its own module so that if we don't need it, we can actually just disable it. I2C is another example. Parallel display bus was actually always split out, but the ones that ended up in display IO originally, we've now split out too.
Right, so they're now at the top level.
Right, there's separate modules that we can turn off and on in order to save space if we want to.
So we talked about seeing things. I would say also for listening to things, there's a lot of there are some new audio effects that were put in, and some revamping of the filter audio effects in Synth.io and stuff like that. I'm not so familiar with that, but you'll want to see that, like the way the biquad filter works has changed somewhat, and those of you who are doing audio synth stuff will probably be quite interested.
Right. So Jeff did some of that work, but also a lot of our community members have really taken Synth.io under their wing and really made it awesome. So thanks to all those folks that have shepherded Synth.io to being what it is.
Yeah. And then internally, you won't see this, but we've been merging from MicroPython. We're a friendly fork of MicroPython, and we merged two more previous versions of MicroPython, and we're pretty close to caught up. I mean, we'll wait until after 10 to do the next merge, but we merged MicroPython 1.23 and 1.24. And another major thing that we keep up with is that the ESP IDF, which is the base software for all Espressif chips, we're up to 5.4.1, which is very, very current and has a bunch of fixes, and bugs that were reported to us which we couldn't fix, were fixed. For instance, in ESP IDF, like some things having to do with I2C in certain chips. So we really try to keep up with that stuff.
Right.
So
yeah, and they're always adding new chip support as well, which is a reason to keep up to date.
So,
do we want to take the 2 questions next?
Sure.
I think that covers 10.
All right. The first question, we had a Google form where folks could submit questions, and the first one came in as I learned Swift using Apple's Swift Playgrounds. I'm currently learning Python via Codefinity's web-based lessons. Is there some sort of interactive way to learn CircuitPython?
No, unfortunately. This is actually something that I have been thinking about a little bit. The large language model AI stuff has really changed my view on what coding will be and how people will learn to code. In short, I think it's going to be more reading than writing than it has been. More reading code than writing code than it has historically been. And I think that's simply because large language models are good at generating code. So you're having to type less, but you still have to read and tweak and fix what it generates. So that changes the world, my worldview a bit about how, like, what is necessary to edit CircuitPython code. And then I was thinking about learning CircuitPython actually for the Fruit Jam. We haven't done this, but I was thinking about what that sort of like interactive lesson would be. But it still is like a little tricky because I really do think that like LLMs will be a pretty core part of programming in the future. So like, is it really worth teaching somebody on a Fruit Jam to type, right? Like typing is such a barrier to it. So I don't know. I don't have a good answer. The only other thought I had that is that like an LLM is probably actually quite good at generating a tutorial, especially for Python, because the LLMs have a lot of Python knowledge, especially the core basic bits. So I could imagine actually leveraging an LLM to generate some tutorials for CircuitPython.
I think also we've seen there are people like John Gallagher, Professor John Gallagher at Boston College, who uses CircuitPython in the practical hands-on courses that he teaches, and he's made a lot of videos and presentations. So though those things aren't interactive in this way, I think there'll be you can get a lot going by looking at that stuff. And I think that people like him are going to pursue the directions that Scott is talking about also, like how can they use AI to help teach CircuitPython and other things to their students for maximal pedagogical purposes. And so it's probably worth you can look into that. Maybe Liz could put up his website or something.
And we're actually going to be chatting with Professor Gallagher today on CircuitPython Day. So
Oh, great.
Look out for that video session. We'll later today. And then I will say before technology catches up to the LLMs, we do have the CircuitPython Essentials Guide that kind of has many examples for all the kind of basic built-in functionality in CircuitPython with just a couple of extra peripherals that you need to attach. And I actually have it saved as a favorite. I'll often start code from here. So if you want to work through all of these pages, that would get you a really good head start on learning CircuitPython.
Right. So CircuitPython, like the programming language at its core, is still Python. So yes. References or resources to learn if statements, for loops, functions, classes, all of that is where you really want to just look for regular Python. And then this is a great resource. The Essentials Guide is a great resource for, okay, given that background of what Python is, how do I actually like interface with things in the real world using CircuitPython's APIs?
All right. And the next question that came in, how do I do image processing with CircuitPython?
Again, you don't really. We have camera support in CircuitPython. Jeff did a lot of that work, but we don't necessarily have a lot of image processing functionality. The reason I thought this is still a good question is that there is and Dan referenced this earlier, we are a fork of MicroPython. MicroPython is the original project that we're based on. It's still actively developed by those folks. But MicroPython is what brought the Python programming language to microcontrollers. There is another fork of MicroPython that is OpenMV. So this is like the microcontroller equivalent of OpenCV. So they do a lot of work around camera capture and like ML modeling and detection and stuff. So if you're doing camera heavy, image heavy processing, I'd suggest just looking at OpenMV. If you are in CircuitPython land because you want driver support, we do actually have this layer called Blinka that can go between MicroPython and the CircuitPython drivers. So you can use many of the CircuitPython drivers, not all, but many of them under MicroPython and also under in CPython on a Raspberry Pi using Blinka as well. So yeah, if you're looking to do hardcore image processing, OpenMV is the place to look.
Yeah, and if you just want to do kind of numerical processing in some way, also there's ULab, which is basically a functional subset of NumPy, and that's available in CircuitPython. And so if you're just trying to like do things like scaling or something, or color processing or something like that, maybe you can do a lot of that numerically using that, and it'll be relatively fast because ULab is underneath. It's in C, and it works with C vectors and arrays.
Right. Yeah, and that's also available, I believe, in MicroPython and probably OpenMV as well.
Yeah.
The creator of ULab has done a great job at making it available on all the different flavors of MicroPython.
So is that for questions, Liz? We could talk about like past 10 if we wanted to.
Yeah, I was gonna say that was it for questions. But what do you folks have in mind for the future CircuitPython?
Do you want to start, Dan?
So we expect to. One thing that we're looking at, and Scott has done a lot of preliminary work on this, is to start using Zephyr as the base for CircuitPython. There's actually a Zephyr implementation port in MicroPython too, and we have the beginnings of a Zephyr port in CircuitPython, and Scott picked like 3 kind of disparate but well-supported in Zephyr chips that we could use Zephyr for. So Zephyr provides a lot more of the lower level stuff, kind of like ESP IDF in some ways, but even more operating system kind of stuff. So Zephyr would include like ways to, like, if you want to do I2C, Zephyr would have already provided the layer to do that. Right now, we're using each manufacturer's low-level layers. So the hope with Zephyr is that we could start writing code in a general way, call the Zephyr functions, and then for individual chips, Zephyr would take care of doing the actual hardware-specific work, chip-specific work to implement whatever hardware functionality that we want. Now, there are issues with Zephyr. Zephyr is much more, is kind of built for building one single-purpose embedded stuff. And so there are things like how Zephyr does pin assignments, which we have to kind of work around, things like that, because it isn't really meant for something that's as dynamic as Python or CircuitPython. But we think there are ways around that. It also, there's probably some more overhead, so it's not clear we could use Zephyr for the smallest ports. But we see other manufacturers going to Zephyr. Nordic, with its NRF chips, has wholeheartedly embraced Zephyr. Arduino has started moving to Zephyr for various things. The Espressif is also working on Zephyr things under the covers. So we think it's sort of the right direction to go in. So we would probably start working on that when we're mostly done with CircuitPython 10, but at a slower pace, maybe.
Yeah, I mean, a lot of our prioritization comes around like what platforms, like chipsets we expect to use in the future. The main one on my radar is the ESP32P4 actually, and I don't think that's going to necessarily push us towards Zephyr, but the strength of Zephyr is that it opens up a lot of platforms for us for hardware, for Adafruit hardware in the future. And it also, when I was working on it before, it gives this feeling of like, this is the last time I have to do this. It's like, I don't have to write a Bluetooth driver again, which I have not actually done, but like all the flash storage management stuff, like, oh, I'm not going to have to worry about this again. Another cool thing that I ran into was like, Zephyr actually has SD-RAM support. So whereas like the only way we get lots of RAM right now is through external PSRAM, well, we could actually do SD-RAM support, which is going to be bigger and faster than the external PSRAM. So that's something that could be cool too. And then also thinking about doing multi-core. What does multi-core mean for CircuitPython? And background task management, that sort of thing as well is something that we hope to inherit from moving to Zephyr, but that's going to be a long process. I think more immediately the Zephyr work is going to depend on whether we have a chipset that we're really interested in. And then the P4 is probably, like, I think Espressif is still focused primarily on the ESP IDF. So I fully expect us to stay current with ESP IDF and be in that land for the P4. And some of the exciting things about the P4 is that it has higher speed camera and display interfaces, particularly MIPI CSI and MIPI DSI. And so those are definitely two things that we're going to want to add support in CircuitPython 4. Part of what Adafruit does and CircuitPython does is make it accessible to access, make technology accessible to people that is like quite common in consumer goods. So like cell phone screens and cell phone cameras are using, I think, MIPI, CSI, and DSI interfaces. So by like getting us to that point where we're doing higher speed DSI and CSI, we're actually going to unlock a lot of products that are based on parts from phones. Just like accelerometers that we sell are popularized by phones and stuff. So I think I think it's going to be interesting whether like we're really doing a lot of Zephyr or whether we're doing more P4 work. I'm not sure of the state of P4 support in the expressive Zephyr stuff. That's something worth looking at for sure. Trying to think of other exciting things. But yeah, better displays, better cameras. I'm not sure we would do a lot of all of the ML image detection stuff that OpenMV does. We would need to have a use for that. But yeah, that's what's on my radar. I'm also got dad brain. If folks don't know, I'm only working about quarter time, so I'm only working about 10 hours a week right now for the next few months, and then once my youngest goes to daycare, I'll be back full time and have a little less dad brain, and have more cycles to do things like ESP32P4 and Zephyr.
And I think also we would see that there's more sort of consolidation and we're moving faster on some things, but we've been nice to, we have a bunch of bugs and features that we still like to fix. For the upcoming first 10.0 release, we've only got like 8 or 10 issues that we'd really like to fix before that initial release, but we have maybe 60 something to fix later in 10. So it'd be nice to make sure that we have a nice stable platform as we move on to 11.
Yeah, and we also find with like 10 that like 10 is stable enough when we start recommending it to people on the forums of like, oh, this doesn't work in 9. It's like, did you try 10? Like, and it is pretty interesting. Like there is a lot more people that use the stable release than the unstable release. So it's good for us to switch over to the newest one when we think it's ready, which we'll definitely do before I'm back full time. All right. Do we have final thoughts? Do you have any questions, Liz?
No. I will just say I mainly use CircuitPython in my day-to-day Adafruit, and it's still very easy to get drivers going and have a easy API to manage all these boards. So really appreciate the work that you folks are doing.
Yeah, I mean, I've also thought a lot about, and I think you've been doing this, using LLMs to generate some of that stuff. And you're probably finding, I thought it was interesting that sometimes they do old style things. So like this display IO example where we're like changing the module names, like it will somehow know that like the old way existed. And so I think there is a world for us to like have some shared resource about like, oh, if you're doing CircuitPython with an LLM like Cloud Code, like here, just tell it these things to get it like up to date, like get it in the right frame of mind to help you with what you're doing. Like here's a link to the docs, here's a link to the latest stubs, like here's a link to a file maybe that says like all the changes in major versions, so that it can keep all of those things in mind.
Yeah, there's definitely a way to prompt for CircuitPython with these LLMs. I found that can be something we talk about in the future too, making that kind of more ubiquitous and available for folks to look at.
Totally. And then I think the other piece of that is like with the agentic stuff is like the feedback loop. So like how do you set up Windows, Linux, Mac so that you get like serial output back into the LLM automatically is quite powerful. It can also mean that it spins out in the wrong direction, but that's
always a risk.
Yeah, but that's what like the prompts, like common prompts can help of like, if we always see that like this error happens and then the LLM tries to do this other thing that's not right, we can give clues to it. So I think that's definitely something that we're going to want to explore. And I guess that I would say that that's in that vein that of like how easy it is to get started with CircuitPython has always been a focus of ours. So like we've done the Bluetooth interface, so you can use an app to edit. You can do code.circuitpython.org that Melissa's done. and you can edit that way. We have the web workflow that's actually been quite popular, where you can do CircuitPython.local and edit over the network that way. So we've always tried to push those boundaries, and I fully expect us to really, in the coming year or two, like really look at LLMs as a tool that we should teach people on how to get it to help with CircuitPython. We've seen people on the forums come in like, this doesn't work, and it's like, but like we need to teach people like what things it's good at and what to context to give it for CircuitPython.
All right. Well, thank you so much, Dan and Scott, for joining us in the session. Definitely
welcome.
covered a wide variety of topics, all things CircuitPython. And I will say, too, if you want to continue following CircuitPython development throughout the year, there's the weekly meeting where we discuss, the stats week to week and what folks have been working on. So definitely check that out on Discord if you're interested. And with that, we can wrap up the session. Thanks so much, folks.
Thanks, Liz, for putting
Thank
this
you.
all together.
Of course, yeah. Good one.